Yo, this is Mr. O. Yo, this is Mr. O. Today we're going to learn about congruent chords and arcs. How do we know if this blue chord, let's say AB, is equal to the chord CD? We can say that the two chords are congruent if the corresponding arcs are congruent. So if the arc AB is congruent to arc CD, then we can say that chord AB is congruent to chord CD. Okay? Another thing for us to know if the chords are congruent, if the distance from the center is equidistant, means say if this is E and this is the center F and this is G, if EF and FG are equal, then we can say that the two chords are congruent. And that will happen if this is a 90-degree angle. Because the shortest distance from a point to any line is the one that's perpendicular to it. Speaking of perpendicular, if I have a center here, and this is the radius, that is perpendicular to a given chord, which makes 90 degrees here. We can say that this one here is D. This is A and B here. If the radius CE is perpendicular to the chord AB, we can say that this and that one will be congruent. So basically, the radius bisect the chord AB. So if EC is perpendicular to AB, so what happened there? We can say that AD is congruent to PD. Okay? So two chords are congruent if and only if their corresponding arcs are congruent. So if we say, in this given the figure in the left, if arc AB is congruent to arc CD, therefore AB is congruent to chord CD. Chords are congruent if and only if they are equidistant to the center. Meaning, say in this picture here, if point E, the center, EF and EG are congruent. So if EF is congruent to EG, we can say that AB is congruent to CD. And the last idea here, if a diameter or a radius is perpendicular to a chord. So we say this one here makes a 90-degree angle there. Same thing with this. What happened? Then it cuts this into equal parts, so it bisects the chord and its arc. So therefore, if that bisects, so we know that EH is perpendicular to AB. If that is so, we can say that these two here are going to be equal. So I can say that AF is congruent to BF because those were cut by bisector. And the arcs, the arc AH is congruent now to arc BH. Okay? Let's apply the concept there. So we have here a circle, and it says here that this chord is congruent to that chord because of this thick line here. So therefore, this arc here and that arc there has to be equal. So 7x plus 24 is equal to 115. Subtract 24 on both sides here. That will give us 7x equal to what? 191, right? And divide by 7, x here is equal to, what's 91? Divide by 7. Looks like 13. 91 divided by 7, it's 13. Kaboom. Next, I have here circle with arc LM is congruent to arc JK. So therefore, if the arcs are congruent, therefore the chords has to be congruent. So we can say that 18x minus 2 is equal to 52. Add 2 on both sides, 18x is equal to 54. Divide 54 by 18, that will give me x equal to 3. Boom. If MP, where's MP? MP is right here. It's the segment from the center to the chord here of JK. And if MP is 5x minus 34 and PN, which is this red one, is 2x minus 4, find MP. So since this arc here are congruent, we can say that this chord here are congruent, and the MP and PN must be equidistant to the center P. So they have to be equal. 5x minus 34 is equal to 2x minus 4. Minus 2x here, plus 34 here, plus 34 there. That gives us cancels out. 3x equal to 30, so therefore x equal to 10. Find MP. MP is right here, so we're going to plug in the 10 right there. That gives us 5 times 10 minus 34. 50 minus 34 is going to be 16. MP is equal to 16.